Okay, welcome to class 3, video 2. In the first part of this class, you did an argument sorting exercise and watched a video about it. After that, you should have done a reading and an exercise that explained some of the technical terms that we use to describe the patterns that should have emerged from the sorting exercise. To review, the easiest way to do the sorting exercise was to actually put the arguments in 3 piles. You could do a 4-pile version. We'll just talk about the 3-pile version. There are the good arguments. There are and these are the best arguments. There are the arguments that are like the best arguments, but contain false statements, false premises, and generally these were silly premises. And then there were arguments that just didn't work at all, right? That latter category we could divide further into arguments that had bad inferences and arguments that had false premises, but we're not going to do that. So the terminology from that was the idea of a sound argument, an argument that was valid but not sound, and an invalid argument. And that was the terminology that was introduced in the reading. And so the first exercise set would have had you separating valid from invalid arguments. That is, you're not worried about whether something belongs in the top pile, the sound pile, or the valid but not sound pile. So now I'm going to go into more detail about those this terminology. But basically the idea is, as I said before, there are 2 ways an argument can go wrong if you just look at the argument in itself. One or more of the premises can be false, and the inference could be weak. And I said in the previous video that this corresponds to 3 questions you should always be asking. You want to be checking the reasons. Are the premises true? Check the reasoning. If the premises were true, would they support the conclusion? That's what corresponds to the previous 2 ideas. And then, because this is a practical course, you want to be checking for missing information. Has any relevant information been omitted from the premises? So most of the rest of your reading then was actually about this middle question, trying to figure out how to, giving you terminology for checking the reasoning. And as I indicated already, the first bit of terminology here is the term valid. So I'm going to move to an earlier video where I talk more about validity and soundness, and after that we'll do some of the exercises, and then we'll get into the deeper level where we talk about strength and cogency in the last set of exercises. All right, so when we talk about arguments, classically, people have gone looking for the very best arguments. This is mostly a bit of the history of European philosophy, and they came up with this word to describe the strongest arguments, valid. And because we want to distinguish the truth of the premises from the strength of the inference, we need to distinguish valid from sound. So these are 2 separate terms we use to evaluate arguments. We're going to say that an argument is valid if it is impossible for the premises to be true and the conclusion false. That's an odd phrase, but we need to just sit with it a while and really get it down. We're not claiming that the premises are true. We're just saying that if they were true, there's absolutely no way the conclusion could be false. And then if it turns out that the premises actually are true, that's a bonus, and we say that the argument is sound. So when you check the reasoning, if the reasoning is perfect, absolutely perfect, we say that the argument is valid. If after that you check the reasons and you find that they are true, then the argument is sound. All right, remember this slide from a video last week? We defined an inference as the connection between statements in an argument. So when you move from the premises to the conclusion of an argument, you are making an inference, right? The connection between premises and conclusions is the inference. So when we say that an argument is valid, what we mean is that the inference, that connection, is perfect. So it's about the arrow. When we say that an argument is sound, we say that it's valid and, go back, the premises, here just premise 1, premise 2, they are true. Okay? So here is one of the standard examples of a valid argument. All people are mortal. Socrates is a person. Therefore, Socrates is mortal. Right? If those two premises are true, there is no way for the conclusion to be false. Also, it's sound because we know those two premises are true. Now, think about this one. This argument is also valid. All people are carrots. Socrates is a person. Therefore, Socrates is a carrot. So this is an argument that is valid, just as valid as the last argument, but it's not sound anymore. So again, an argument is valid if it's impossible for the premises to be true and the conclusion false. It's about the relationship between the premises and the conclusion, right? So there's one possibility that's being ruled out here. True premises, false conclusion. We're ruling that out. So look at these two examples again. In the first example, we have true premises and a true conclusion. In the second example, we have false premises, one false premise, that all people are carrots, and a false conclusion. Neither of those are ruled out by the definition of a valid argument, which just says the premises can't be true and the conclusion false. So both of these, that's one reason why both of these count as valid. This, on the other hand, is an invalid argument. All people are mortal. Socrates is mortal. Therefore, all people are Socrates. Right? Now you've got, we just rearranged the premises and the conclusion, and or actually we just rearranged some of the terms in the conclusion, and now we get two true premises and a false conclusion. And so that is obviously the definition of an invalid argument. But now consider this. All dogs are mammals. All domesticated canines are mammals. Therefore, all dogs are domesticated canines. Think about that for a second. Is that valid? It already says on the top, it's invalid. It's not valid. All these statements are true, but the way the argument is structured, the premises could be true and the conclusion false. And the way to see that is to substitute in different terms. So, I see what's going on here. So, even though all the premises are true, they actually don't provide support for the conclusion. And we can see this by substituting cats for domesticated canines. Right? All dogs are mammals. All cats are mammals. Therefore, all dogs are cats. Suddenly, we have the same argument structure, but true premises and a false conclusion. So with this argument, when you look at it as this structure, you can see that it is possible for the premises to be true and the conclusion false, and therefore the argument is invalid. All right. Validity is a very special kind of compliment that you can pay an argument. It's the highest possible compliment you can pay an argument. And in the real world, most arguments aren't even trying to be valid. There are only a few contexts where we really encounter valid arguments. And these mostly have to do with kind of arbitrary systems or systems that might be viewed as arbitrary. Well, okay. Grammatical rules, logical rules, legal codes, mathematics, logical games, and puzzles. All of these are situations where we just pretend like our definitions are incredibly rigid. So if you want to know a mathematical statement, you can reason to the truth of that statement with validity. 2 plus 2 equals 4 can be proven from other premises with validity. Well, there's more complicated. Math, pure math, not math tied to the messy physical world, but the idea of pure number, this is a realm where validity is possible. Also, if we've got truths that we accept so naturally that they seem like mathematical truths, then we can go ahead and say that. So arguments with premises like all people are mortal or unsupported objects near the earth are pulled toward the center of the earth, those all statements there are universal enough that we can say that there's a valid argument that's possible. Valid arguments are also possible in hypothetical situations if we just imagine that we've got a perfectly verified truth. So we can say all humans have purple hair and 5 legs, or all people are carrots. As long as we're imagining that these universalizations are as true as 2 plus 2 is 4, then we can make validity possible. Okay, now that we have the concept of validity down, let's look at some of the homework problems from the first set. These are problems where you only have to say whether the argument is valid or invalid. But of course, you have to put it in standard form first before you can even judge that. So let's just run through a few of these and see how they go. So all dinosaurs are people and all people are fruit. Therefore, all dinosaurs are fruit. This should be a familiar pattern to you now. There's your indicator word. There's your conclusion. Conclusion. All dinosaurs are fruit. And it's full of silly examples. So that could mean that, well, it means it's definitely not sound. It still could be valid or invalid depending upon how the rest of everything is arranged. So we've got P1, P2, P1. All dinosaurs are people. P2. All people are fruit. Indicator. Therefore, but you can see that this has the same pattern that you generally find in, this has a pattern that you find in valid arguments, right? Essentially, you have a group of inclusive circles. You imagine this is the group of dinosaurs, and all of them belong to the larger group of people, dinosaurs, people, and all of those belong to the larger group of fruit. It actually doesn't matter what nouns you put in here. You know this argument form is valid. So this is valid. It's not sound, but we don't even need to worry about that. Okay, let's take a look at the next one. This is another one that is conclusion end, right? All people are Socrates. And then again, the indicator is therefore. It's a false conclusion. That's still not enough to tell us whether or not it's valid. Valid arguments can have false conclusions. Invalid arguments can have false conclusions. Let's take a look at this. All people are mortal. That's true. I'm just going to make a little note. And Socrates is mortal. That's also true. But the conclusion is false. True, true, false. That is the one thing that we know makes an argument invalid. Right? So you've got silly ideas, you've got, well, actually you don't have silly ideas, but you do have a silly idea in the conclusion. But it's really the structure of it that makes it invalid. The inference just doesn't work here. All right. We're continuing with these all arguments that involve all statements. We've made things a little bit more tricky because here's the therefore and a conclusion in the middle. Conclusion middle is the weakest way to argue, and it's often the hardest to recognize. So indicators, therefore, because. I'm not going to bother to classify them as premise or conclusion. So now the conclusion is that Fido was a mammal, and then the other two statements are the premises. All dogs are mammals, and Fido is a dog. And again, this is valid because it's got that structure of three inclusive categories, right? So, or two categories in an individual. So you've got the category of mammals, and then the category of dogs, and then Fido is in it, right? So that's a valid structure. No matter what words you use here, that structure is valid. Okay, I'm not going to do all of these. I'm actually going to skip down now to 7, and the answer sheet will be online, and you can use that to check your other answers. Okay, 7, if George Washington was assassinated, he is dead. George Washington is dead, therefore George Washington was assassinated. Conclusion last. I'm not doing much to fuss around with structure here. GW was assassinated. And again, that's obviously a false conclusion. But your premise, if GW was assassinated, he is dead. And P2, he is dead. These are both true statements, right? If George Washington were assassinated, he would be dead. And he is in fact dead. Therefore, he was assassinated. But you've got a false conclusion. So if you've got true, true, false, you know the argument is invalid. The other thing you can see here is that the structure of this doesn't work. This is if A, then B, B, therefore A. It's backwards from the way a proper argument of this format would work, right? Normally you would assert A and then get B, but here you're going the opposite direction of the if-then statement, so it just doesn't work. So I'm going to skip a few more. I'm going to go down to 10. Like I said earlier, Validity is the highest possible compliment you can pay an argument, and most arguments aren't even trying to have valid inferences. Most of the time we are just gambling on probability, and this is really what problem 10 brings out. So I'm going to switch over to a video of me doing problem 10 to show that although it's not valid, it's still a good argument. But let's just check this out. A forest ranger is surveying a park, and he says, "I can tell that bears have been down by the river because there are tracks in the mud. And tracks like these are made by bears in almost every case." So now remember, with the conventions that we have set up for this course, the part in italics at the beginning represents context. And a lot of times context won't matter, but sometimes it does, and I like keeping that there to emphasize the idea of context. Arguments occur in context. So this argument, this is an argument, and you can tell it's an argument because it has an indicator word. It's got this because, right? And that means that the first statement is the conclusion. I can tell that bears have been down by the river. We're going to drop out, when we put this in standard form, we're going to drop out the I can tell that, and we're just worried about this proposition that's about the world. We're not worried about the thinker. So we say, bears have been down by the river. We'll draw a line above it. That's our conclusion. And that means that the other two statements are premises. There are tracks in the mud, and tracks like these are made in almost every case. Oh, but wait, there's that word almost. That means this argument is invalid. Nevertheless, it looks like it's a pretty good argument. So now we're going to have to talk about a different kind of compliment that we can pay arguments. We said an argument is valid if the conclusion must be true if the premises were true. A slightly weaker compliment we can pay an argument is to say that the conclusion is likely to be true if the premises are true. So deductive validity is the best an argument can be as far as its inference is concerned. And if it's not deductively valid, but it's still pretty good, we can say that it's strong. One interesting thing about strong arguments is that strength actually comes in degrees. Validity is a black and white property. Arguments are either valid or they are not. Strength comes in degrees. How strong does an argument need to be before it's strong enough? Well, that depends on context. For instance, in the United States, in a criminal case like murder, you have to prove things beyond a reasonable doubt. Beyond a reasonable doubt is slightly less than validity. Validity is beyond any possible doubt, beyond a shadow of a doubt, they say. Beyond a reasonable doubt is about as close as this as you can get. You might be able to come up with some possible doubts, but they aren't reasonable. We will return to the question of how good an argument needs to be as far as its inference goes before it is called strong after we finish talking about the basic idea of strength, run through a few examples, and look at the homework. So, an argument can be strong. We now have three terms. Valid, sound, strong, and then we want to introduce another word, cogent. And then cogent is the equivalent of sound for arguments that are strong. So an argument is strong if the premises would make the conclusion likely if they were true. And then an argument is cogent if it is strong and the premises are true. So check the reasoning. The reasoning is good enough. We call it strong. What counts as good enough? That's going to depend on the context. In the case of a jury, you use the standard of a reasonable doubt. That's because it's a criminal trial with the defendant's life on the line. In a civil trial with a lawsuit, there are other standards like the preponderance of evidence. We'll talk about that when we get to burden of proof. In any case, we just say an argument is strong if the reasoning is good enough, and we say that the argument is cogent if it is strong and the reasons are true. So this is the full array of complements you can pay an argument. Valid, sound, strong, cogent. You need to know these terms. Okay. The difference between the world of valid arguments and the world of strong arguments also gets a name. We talk about the difference between deductive arguments and inductive arguments. Mathematics is generally pursued as a deductive science. And that's because the proofs of mathematics are supposed to be valid. Anything about the physical world, the empirical world around us, the world that we can sense, is going to be inductive. Arguments about that merely aim at strength. So Sherlock Holmes, in I think most of the instantiations going all the way back to the original, will say that that it's deduction, Watson. It's elementary. He's actually not doing deduction there. He's doing induction because it's about the physical world. So we put our terms together like this. The realm of deduction, if you're in the realm of deduction, things are valid or sound. If you're in the realm of induction, things are strong or cogent. Another common thing to say about the difference between inductive and deductive arguments is that deductive arguments are thought to only rephrase the information that is already given. So the reason why you are able to be so confident in the truth in this inference is that essentially the conclusion means the same thing as the premises. Inductive arguments, on the other hand, are thought to involve taking a risk. The conclusion is thought to say more than what the premises do. And this is easiest if you think about one of the classic examples of an inductive argument, which is a generalization. So suppose you know a couple of dogs, and your dog and your friend's dog both like cheese. You make a generalization. All dogs like cheese. That's an inductive argument because you're moving from a statement about a few dogs to a statement about all dogs. It means you're taking a risk. You're going beyond the information given. And that's why the argument could at most be strong. It can never be valid. Okay, so now I'm going to run through a few examples of arguments that can be valid or strong or cogent or sound. And then we'll take a look at the homework, and then we'll come back around and talk about things like standards of proof. All right, so here's an example of a valid argument. Start with a hypothetical statement. If the deficit goes up, then deficits will rise. Then interest rates will rise. Deficits are going up, therefore interest rates will rise. If you imagine that first statement is a perfectly verified if-then statement, then the argument is valid. It's if A, then B, A, therefore B. That is a structure that is always true. Here's an example of a strong argument. I have seen 1,000,000 swans. They all are white. Therefore, all swans are white. This has been an example of an induction for the longest time because in Europe, all the swans are white. And so when a European a Dutch guy, I think, finally got to Australia and saw a black swan. That was, you had like hundreds of years of this generalization. All swans are white. Of course they're white. And that generalization becomes false when you travel to Australia from the European perspective. So that kind of generalization about the physical world can be changed by more experience with the physical world. So here's another example of a valid argument. If the moon were made of green cheese, mice would love it there. The moon is made of cheese, therefore mice love it there. Now we've got a false premise, but it's got the same structure as the first argument, actually. And it's a valid structure. If A, then B, A, therefore B. Okay. So look at this argument. Do you think it's valid? Premise 1. If roses were green, money would grow on trees. It's an if-then statement. Premise 2. Roses are green. Conclusion, money grows on trees. It's valid. It's the same structure that we saw before. All right, I'm going to leave you with one final argument. This one is cogent. The sun has risen every morning for as long as anyone can remember. Therefore, the sun will probably rise tomorrow. You may think of the sun will come up tomorrow as as an absolute certainty. But by by the standards that gave us mathematical validity, it's not a certainty. It is merely the best we can do with inductive reasoning. And that's because all of inductive reasoning depends on a single premise, that the future will be like the past, at least a little, right? And whenever you're working off of the idea that the future will be like the past, you're dealing with inductive reasoning. Okay. For this set of exercises, you have to determine if the argument is valid, strong, or weak, and you need to explain your answer. I actually didn't write down that you have to put it in standard form. I'm going to go ahead and do that anyway because that's just something you should be in the habit of doing. So check this out. On 23/06/19 in 2003, 06/19 in Norfolk, Virginia, a violent storm blew through and the power went out over much of the city. So the storm caused the power to go out. Its conclusion last. P1. P2, P1, there was a storm in Norfolk. P2, the power went out. Conclusion, the storm caused the power outage. Indicator. So, all right, so this is a great example of an inductive argument that is strong, right? This isn't a perfect argument. It's not absolutely valid. There are other reasons the power might have gone out. Maybe squirrels were eating through the power lines. Maybe it was terrorism. Maybe terrorist squirrels ate through the power lines. These are all possibilities, but they're not very likely. We all know from ordinary experience that severe weather downs power lines and causes power outages. So we're going to say strong if the premises are true, the conclusion is likely. And I could spell that out further by just asserting all the details that I just did. All right, this next one awkwardly goes across the page, but that's fine. All human beings are things with purple hair, and all things with purple hair have 9 legs. P1, P2, flip it over. Therefore, all human beings have 9 legs. Conclusion, all humans have 9 legs. P1, all humans have purple hair. P2, all things with purple hair have 9 legs. Indicator, therefore, and this is clearly valid. It is a classic valid argument form. And actually, if we were studying formal logic, we would learn the names of this exact style of argument and that sort of thing, but we don't need to worry about that now. Okay, again, I'm not going to hit all of these. I'm going to hit a couple because they are ones that throw people off, and often it's because you're not clued into certain standard logical forms. So let's take a look at this one. The conclusion is that the king had 18 number 1 hits. The premises are Elvis Presley was known as the king, and Elvis Presley had 18 songs reach number 1 on the Billboard charts. So what's going on here is that P1 is asserting that two entities are the same, right? P1, Elvis is the king, and P2, Elvis had 18 number 1 hits. Conclusion, the king had 18 number 1 hits. Indicator so. This is valid. What's going on here is that you're substituting 2 names for the same thing. Substituting names is a valid inference. Actually, not in all contexts, but in this context. So the idea is that, as I said before, deductive arguments don't go beyond the information given, and that's sort of what's happening here, right? We could also say the conclusion could also be that Mr. Presley had 18 number 1 hits. Just changing the name doesn't change the truth of the proposition. So we're not going beyond the information that's given in the premises. All right, one more. Jack has purple hair and purple toenails, therefore he has toenails. Actually, the only premise you really need here is that he has purple toenails, right? And it's just a property of having purple toenails that you have to have toenails in order for them to be purple. We can do it like this. P1, Jack has purple hair. P2, Jack has purple toenails. Jack has toenails. Indicator. Hence, it's valid if you have purple toenails, you must have toenails. And again, just like the thing has to exist for the property to apply to it. And so it's a purely logical point, and that's how you can tell that the inference is valid. Okay, so I'm not going to run through the rest of these. The answer sheet is online. And now I want to fill in a few more details about what to do when you are evaluating arguments, how to go about it in a practical situation. So basically, we have two main styles of argument, the deductive and the inductive. If you are using deductive reasoning, you are trying to have perfect inferences. Your goal is validity. If you are using inductive reasoning, you are trying to have good enough inferences. And this is mostly how we operate in the real world. Your goal is strength. Each of these styles of reasoning have separate evaluative terms associated with them. If we are being deductive, the terms we use are valid and sound. If we are being inductive, and the inferences merely need to be good enough, then we use the evaluative terms strong and cogent. The thing that we're going to use when we evaluate arguments is called an argument scheme or an argumentation scheme. An argumentation scheme is an established style of argument that has certain established virtues and drawbacks. You can think of them as subtypes of the standard form that we've been putting arguments in so far. So in this class, we're going to cover 4 subtypes of standard form: argument by analogy, argument from authority, also called argument from testimony, inductive generalization, and instantiation syllogism. Argument by analogy is when you say that because two things are similar in some ways, they are probably also similar in other ways. Argument from authority is when you say that something is true because you heard it from a reliable source. So, inductive generalization is when you make a generalization based on knowledge of a few examples. And instantiation syllogism is when you start with a generalization and apply it to a new case. All of these methods of reasoning can be used well, but they can also be used badly. Some of them are used badly so often that we sometimes simply think of them as fallacies. So sometimes the argument from authority is referred to as a fallacy. But it isn't. As we will soon discover, life is full of times when you need to take someone else's word for it. Really, what is going on is that for each of these styles of argument, there is an associated fallacy. For instance, for inductive generalization, the associated fallacy is hasty generalization. The thing to see now is that each of these styles of argument has a different version of standard form associated with it. We've already been putting arguments in standard form, which is the form you see at the top of this diagram. we have some premises, and then you draw a line, and then you have a conclusion. What we're going to see going forward is that different subtypes of standard form. You get a little preview of that below. For instance, in argument by analogy, we have two premises and a conclusion, but each line of the argument has to be structured a certain way, right? So premise one is two things are similar in a way that we know. Premise two is the reference analog has this inferred similarity, and the conclusion is that the target analog has this similarity. We'll get to all of that shortly. With each style of argument scheme, we're going to need a way to tell when the argument is being made well and when it is being made badly. We do this using critical questions. These are questions you should ask once you have analyzed an argument by putting it in standard form. So we've already seen the basic critical questions. So if you just put an argument in the standard version of standard form, we can ask, are the premises true, or at least plausible? We can ask, do the premises support the conclusion enough given the context? And we can ask whether any relevant information has been omitted from the premises. So just as there are subtypes of standard form for the different argument schemes, there are also different subtypes of critical question. So sometimes you'll be asking the general critical questions, but other times you will be asking the more specific, the more specialized kinds of critical questions. So we can do the same thing for the critical questions that we did for the argument in standard form. So at the top of this diagram, you've got the general critical questions. Are the premises true? If the premises were true, would they support the conclusion? Has any information been omitted? And then for the specific styles of argument, we refine those critical questions to get more specifically at how this kind of argument might go right or wrong. So, like I said, for each style of argument, there is a fallacy. A fallacy is an argument that appears to be good, that appears to be valid or strong or sound or cogent, but it is not. A fallacy could also just be called a common mistake in reasoning. Okay, so here are the basic fallacies. For an argument by analogy, we're going to have an argument by false analogy. For argument from authority, we're going to have argument from bad authority. Inductive generalization, the fallacy is hasty generalization. And for instantiation syllogism, the fallacy is suppressed evidence. But all of this is mostly preview. Right now, you just need to know the basic evaluative terms: valid, sound, strong, and cogent.